Number one, I have handed back tests. If you want your test back, you need to come and get it from me. Your grade is in Moodle, and the score that's recorded is 1 point higher than actually what you scored, because the top score in the class was a 99. And so I added 1 point down to everybody's test. So, are there any questions on where we left off last time in section 2.1, or was that pretty chill? Okay, what I'm going to do today is I'm going to do about 4 or 5 more questions out of section 2.1, and then we'll jump into section 2.2. Okay, there's not a ton more that we need to do in 2.1, and I have a feeling I forgot my purple marker that works. Hi. Your last name is Dunn, right? Brooke. Yes. Okay. Here's your text. Thank you. The curve was adding 1 point on, so you probably already saw it. But yeah, I saw him. Okay, and I will post test solutions later. So what I want us to do is just go through a few more examples in this section 2.1. Okay, so I'm just going to write it a little bit differently just to make sure that you're all prepared for the different ways that you are going to see all these fantastic things. Okay, so suppose I tell you that f of -1 is equal to 4 and f of 5 is equal to 1. What if I want you to find the equation of the line passing through these points? Okay, why is this one slightly different? We don't have it written as ordered pairs. So what the extra leap here is taking this information and writing them as ordered pairs. It's just a crucial connection you make. So how do I write this first one as an ordered pair? -1, -4. And how about the second one? 5, 1. Okay, what's my next step? Yep, we're going to find our slope. So who should I start with in my numerator, 1 or 4? Okay, we'll start with the 4. So since I started with this y value, who do I need to start with in my denominator? Its corresponding x value. Well, what is 4 minus 1? Yay! And what's -1 minus 5? -6. So would you all grant me that our slope is -1/2? So thus far, we know that this is our equation. Okay, remember what determines the equation of a line is your specific m value and your specific b value. All right, are we done? No, what do we need to find now? We got to find b. Okay, so what do we do in order to find b? Well, notice we're given a couple of ordered pairs. So what we can do is take either one of these ordered pairs, plug them in, and solve for b. Does it matter which ordered pair we plug in? No, and it better not, right? Because there's infinitely many points on any line. So it better not matter which ordered pair you plug in. So who do you want to plug in just for the fun of it? Neither one of them turn out that pretty. 5, 1, okay. Y is equal to 1 when X is equal to 5. So do you agree I get 1 is -5/2 plus B? To get B alone, what do? Add 5/2. So I claim we get 7/2, right? 2/2 plus 5/2 is 7/2. Now, I don't care whether you write it as an improper fraction, a mixed number, or a decimal. They're all equivalent. You okay there? All right. Suppose I have this one instead. So suppose someone has a gym membership. And the gym membership comes with a base charge and then a fee per personal training session. Okay. If 2 sessions cost a person a total of $125, and this is incorporating the base charge, and 5 sessions cost a total of $260, what is the rate for each personal training session and what is the base cost? So this one looks a bit different because what I'm doing is I'm using all words instead of just having M's and B's. Okay. When we want to find, so if I write the equation of our line as y equals mx plus b, will you grant me that this is going to be linear because we have a base charge plus a fixed cost in terms of each training session? What are we finding here when we want to find the rate for each personal training session? That's our slope, right? That's our rate of change. And when we want to find the base cost, so just for heading to the gym, what is that? Isn't that our B value? In other words, let's let X represent the number of training sessions. And those of you on Zoom, if you have any questions, you've got to ask. Can I write this first information as an ordered pair? What does it look like? 2, 125, and this next one is 5, 260. Right, you all agree that the total cost here is going to be the cost per session times the number of sessions plus your base cost. Well, which Y value do you want to start with? 260. So we'll do 260 minus 125 over 5 minus 2. And I claim we get 45. I did the math already. So what is the rate for each personal training session? It costs $45 per session. Can I find my base cost now? You bet. We have y equals 45x plus b. We can take one of these ordered pairs, plug it in for x and y to get our value of b. I'll take this one just because it looks a little more tolerable. So we get 125 is equal to 90 plus b. We can subtract 90 from both sides, and what do we get b to be? 35. So apparently the base cost of this gym membership is $35 a month. That's kind of right in line with what it is here at the rec center, isn't it? Do you all go to the rec center? No. Me either. But I like the pool. I go to the pool sometimes. All right. So if I wanted to write the equation of the total cost, would you grant me it's 45x plus 35? Cool. Questions this far? All right. I am now going to share my screen with the MyOpenMath. Hold on. First, I have to open it. There it is. Okay. Okay. So we're about ready to assign this section. But I just want to do a couple of problems together just to be sure you're all cool about this. Okay. So this first one I'm looking at is number 4. This is my version. You know, you're obviously going to have your own. And all they want us to do is find the slope of this line. Okay. You have multiple ways of doing this, and I'm just wanting to point out a couple different ways you can do it. You can take 2 definitive ordered pairs that this goes through, right? Like here's a definitive one, and here's a definitive one. And you could plug that into your slope formula, and that would give it to you. Are you with me there? Okay, if you have a question, you gotta speak out. Another way you could do it is find 2 definitive points and measure the rise over run. Like literally, like here's a definitive point and here's a definitive point. So to get from here to here, wouldn't we have to rise 4 and run 5? Shazam. So my point is, do it whichever way works for you. Cool? Awesome. And one more. Number 12. In this one, we want to select all of the following tables which could represent a linear function. And what I want to mention here is the distinguishing thing with a linear function is that it has a constant rate of change. In other words, as your x values increase by however amount, your y values also do. Okay, so let's go through each of these and determine which ones are linear. Notice they change the increments here. So don't get caught up in like just looking at the numbers. You have to compare the increments. Do you agree here as my X changed by 5, my Y changed by 15? Here, okay, so I'm going to annotate this. So as my X changed by 5, my Y changed by 15. What's the slope here? 3. Okay, is my slope going to be the same here as well? Well, notice here, what did my X's change by? 10. What did my Y's change by? 30. I love your enthusiasm. Do we get a slope of 3 here as well? We totally do. And you'll see with this one that you'll also get a slope of 3. So this is one of them. Okay, let's look at the next one. Notice here it changes by 5. My Y values change by 5. What are my function values changing by? Negative 25. Right? 7 minus a negative 18. So here our slope is negative 5. Is that the same change that happens here? And the same, notice these are each going in increments of 5. So are each of these changing by the same increments of 25? Not a rhetorical question. Well, to get from negative 18 to negative 43, don't you subtract 25? And to get from negative 43 to negative 68, I claim we also subtract 5. So here's another one. Do you get the hang of this? I don't want to bore you, but like I want to make sure. Okay, cool. Thank you. I mean, you're all a very quiet class, which is, you know, whatever, that's fine. Every class has its own personalities, but I at least need to know if I'm doing something really helpful or I'm boring you all silly, like don't waste our time. Okay, cool. So should we do the next two? Okay, so notice each of these are changing by 5. So we need to ask, are each of our function values changing by the same amount? They're all changing by 15. So is this a function? A linear function? Yes. Well, we can already say by the process of elimination, they're going to have one that's not a linear function, but let's just make sure. Notice each of these are changing by 5. How do I get from 7 to 32? I add 25, don't I? Am I adding 25 to get from 32 to 107? No. Heck no. Bing, done. You good? Okay. So what I'm going to say, I'm going to erase all that stuff. There we go. Is we finished section 2.1. So, as I always do, I'm going to assign your online homework to be due a week from today, which is the 12th. There we go. Cool. Any questions this far? Awesome. Now you get something fun to do. Yeah. Homework. Yeah. Isn't it fun? Oh my gosh, I was talking about this with a friend. When I was a little kid, I would be so excited to go home and do my homework right away. And my brother used to beat me up because of it, because I ruined everything for him. Yeah, I used to love homework. Anyway, then I grew up and I don't know, it's always kind of, math is fun for me. So. No, I hate grading. Coming and talking about math is my pleasure. Grading math or grading papers is what I'm paid for. That's what I figured. Okay, so let's move into 2.2. Now, I'm sure that you've heard of a lot of what we're talking about, but I want to be sure that you're down with all of the different terminology that we have. Ooh, there is a chat. Oh, yes, Van, thank you. I even got a response on Zoom. Cool. Okay. I think math classes should be totally raucous. I mean, there's nothing more exciting than computing things. Okay. So here we go. This is our x-axis, this is our y-axis, and I have a line here. Okay. So this point here and this point here are very significant. They're going to be very significant when we study all of our functions this semester: polynomials, rational functions, exponentials, and logs. Okay. This point right here is called your x-intercept. Some books call it your horizontal intercept because it's where it crosses your horizontal line, and we don't always use the variable x. But essentially, it's where the graph touches or crosses the x-axis. Okay? But more practically speaking, let's talk about what it means to be on the x-axis. Okay? Our x can take on infinitely many values, but I claim that something is always true no matter where I am hanging out on my x-axis. What is my y value or my function value always equal to? It's always 0, right? I haven't moved up and I haven't moved down. So any x-intercept has the form of x comma 0. And this is really good. It gives us a pragmatic way to find our x-intercept, which you're going to have to be able to do a ton because it's going to help us graph really funky functions later on. Okay. To find it in an equation, you set y equal to 0 and solve for x. In a similar manner, this point right here is called my y-intercept, aka vertical intercept. Again, because it's on your vertical line. And it's where the graph touches or crosses our y-axis. Well, what's true no matter where we are on our y-axis? Have I moved to the right or to the left? No. So what is always true? Yeah, your x value or your input value is 0. So to find this, given an equation, you set x equal to 0 and solve for y. These two things are like way crucial. And this has the form 0y. And my hope is that you're all going to link it to that b value, because that's precisely our y-intercept. Sorry about the noise. I like writing in pencil, but it needs to be sharp. Questions this far? Is this familiar to you? Tell me when I can move this piece of paper. Okay. All right, so let's just play a little bit. This is the equation of my line. Let's find our intercepts. How do I find my x-intercept? Set y equal to 0. So aren't I solving 0 equals 2x minus 12? Can I solve this? One hopes, otherwise I should not be standing in the front of this room right now. Okay, I add 12 to both sides and then divide both sides by 2. So my x-intercept is the ordered pair 6, 0. Now, you can go through and find the y-intercept in the same manner, but my hope is pretty soon you're going to know that this value right here is always your y-intercept. But to find our y-intercept, again, we can say we'll set x equal to 0, and we have 2 times 0 minus 12, which is negative 12. Yes, and they will be momentarily. All right. Questions here? I'm going to do something a little different. I have this line and it wants to be graphed. Okay. When you're given an equation of a line in this y equals mx plus b form, just to be sure we're all on the same page, you always start here. So I will say plot your y-intercept. You with me there? Okay, that's always your starting point. And then from here, from this point, that's why it's called the starting point, use the notion that the slope is rise over run. Now, when I have a negative slope, I tend to just naturally attach the negative to my numerator. You can attach it to your denominator as well. But the way I would look at this is negative 2 over 3 is rise over run. And at an intuitive level, what does it mean to rise a negative number? Go down. So from here, I'm going to go down 1, 2, and then I'm going to run 3. Notice as I'm going from left to right, my line is going down, and that makes entire sense because I have a negative slope. Would anybody want to see how I would do it if I threw the negative in my denominator instead? Okay, so if I wrote it as 2 over -3, and this is rise and run, what we're saying is we're rising a positive number, so go up 2, but now I'm running in the negative direction, so go left 1, 2, 3. And once you play connect the dots, you'd still have the same thing. You with me here? What if I have y equals 5x minus 1? And I want to graph this. Where would I start? I'd start at my y-intercept. Do you all agree that I would start right here at -1? My slope is 5. Wait a minute, how do I write 5 as rise over run? Well, yeah, 5 over 1 is rise over run. So from here, we're going to go up 5, 1, 2, 3, 4, 5, and then we're going to run 1. You with me there? All right. What if I have this? Now, if you're looking at that and you're like, well, what's that? I'm telling you, it's the equation of a line, okay? When we have our lines written as y equals mx plus b, it's a really useful format because you can read off your slope and you can read off your y-intercept. This is called standard form. This does come up, but it's not as useful, right? Like if I wanted you to find your slope and your intercepts here, probably what I would do is I would just get it in the form y equals mx plus b and then read it from there. Okay, so let's just make sure we can do this. So what if we want to find our slope, our x-intercept, and our y-intercept? Well, we can get y alone. Wouldn't we first subtract 3x from both sides? Divide everybody by 5. So don't we get -3/5 x plus 3? Where'd I get the 3? 15 divided by 5. So I can read off 2 of these right from the get-go. What's my slope? -3/5. Which one of these 2 do I know? I know my y-intercept. As an ordered pair, what is it? 0, 3. Can I find my x-intercept? Yep. You can, ooh, I forgot my x there. You can either plug in y equals 0 here or up here. It doesn't matter. These are just different versions of the same thing. I'll plug it in up here just for the fun of it. So to find my x-intercept, I have 3x plus 5 times 0 is 15. Can I solve this? Yeah, what do I get on my left side? 3x equals 15. So what does x equal to? You with me there? Okay, there's one more topic that we need to talk about in this section. And then we're going to just do a couple word problems because I do word problems with everything that we do, because that's really why we do this. But I want to talk to you about a couple of things. Parallel lines. Pretend those are parallel. Parallel lines have something in common. Does anyone know what it is? Yep, parallel lines have the same slope. They have different y-intercepts because they occur in different places in space. But if I'm trudging up this hill and I'm trudging up this hill, it's going to hurt my quads in the exact same way. Okay. So that's a cool thing to know. On the other hand, we can talk about perpendicular lines. Now, lines can intersect in a ton of different ways, but when we talk about perpendicular lines, we're specifically talking about lines that intersect at a 90-degree angle. Okay? These definitely do not have the same slope, right? Because the slope of this line is positive and the slope of this line is negative. So we say, oh, and by the way, the sign that we use for perpendiculars, we tend to write it like that. You may or may not remember it from high school geometry. But we see that perpendicular lines have slopes that are opposite reciprocals of each other. Now that's a mouthful. So we might as well be pragmatic about the situation, okay? If you have the slope of one line, to find the slope of the line perpendicular, what you do is you change the sign. That's what opposite means. Positive, negative, negative, positive. And then you flip it. Okay, because reciprocal just means you bebop your numerator and denominator. So if I know, for example, that the slope of my line is 2/5, do I know the slope of my line perpendicular to it? What is it? -5/2. Suppose I know that the slope of my line is 24. You're not going to get me to walk up that hill. What is the slope of the line perpendicular to it? -1/24. If you're like, wait a minute, how do you flip 24? Remember, you can take any whole number and put it over 1. You with me there? Okay. So what if I want us to find the equation of the line parallel to y equals -5x - 3 that passes through the ordered pair to -12? Can we do this? Okay, notice we want to find the equation of a line. first step, say, okay, we need to find M and we need to find B. I claim we're kind of sort of given M, right? We know that the line that we're looking for is parallel to this line. So do you agree if we know the slope of this line, we can then get the slope of the line we're looking for? What is the slope of this line? -5/1. And therefore, since this line is parallel, doesn't it have the same slope? So thus far, I can say we have -5x plus b. Can I find b? What would I do? Yep, we're given an ordered pair this goes through, so it's certainly better to satisfy the fact that when x is 2, y is -12. What is my b value here? Isn't it -2? All right, one more for the day. What if I want us to find the equation of the line perpendicular to y equals -2x plus 4, passing through the ordered pair -4, -1? Do you want a couple minutes to do it on your own and then we'll do it together? Okay. Take your time, but give me a thumbs up when you have it, just so that I know where everybody's at. Thanks. I'll give you like 1 minute. Okay. Do you agree? We want to find the equation of a line, therefore we need to find M and B. Okay. Well, do we know the slope of the line that we're looking for?
Yes.
Yes. Okay. What do we know? We know it's perpendicular to this line, and the slope of this line is -2. Therefore, what's the slope of our line?
Yep.
It is 1/2. Can I find B? Yep. I know that when X is -4, Y is -1. Well, our numbers even came out nice. -1 is equal to -2 plus B. So what is B equal to? 1. So my line equation is 1/2 X plus 1. So I have a couple more problems out of this section, but these are kind of small sections, but we'll finish this one on Friday and then move forward. Cool? All right, well, I appreciate your participation. I hope you all have an awesome day. And I will see you Friday. And then it's the weekend.